Hi guys, welcome to my channel. Alright, today's segment we are going to discuss about calculation for installation of buildings. Okay, wiring installation calculations for commercial building setup. This is a hotel. Okay, hotel fall under commercial installation category. So I'm going to walk you through the calculation that is associated to installation of building, wiring installation of building. Okay, so this is a first floor hotel building complex. So it's going to be 3 floor. This is also the ground floor. This is the ground floor. So we're going to calculate the ground floor. What we're going to do is to calculate the requirement for the installation, the material required, and the switch gear requirement, and the cable, and sizing of distribution board, sizing of rising mains, that is service mains, and the total distribution board that is required for the installation. Okay, and also size the generator and the transformer and the other associated switch gear systems. Okay, we are also going to discuss about the earthing system. Okay, the type of earthing that we are going to use. All right, so first of all, let me walk you through the parameters that we're going to use. All right, these are the parameters we want to use. Being this, we're going to determine the number of distribution boards that are going to be used for each of the floor, then total number of circuit for each of the floor, then total load demand for the hotel in total from the ground floor, first floor, second floor, and the last floor. Okay. Then we're going to also determine the service mains cable. That is the service cable that is going to be using to feed each of the distribution board. We're going to also consider the voltage drop from the point of service intake to each of the distribution board. All right. Okay, because the service cable from the busbar chamber position to each of the DB is going to be more than 100 meters. Okay, so we're going to consider our voltage drop. So our switchboard or our switch bus bar rating, we're going to consider that as well. And we're going to also discuss about diversity factor. We're going to apply diversity factor in our calculation. We're going to also consider 25% spare MCB for each of these distribution board. Okay, these are the requirements stipulated by the regulatory body. Okay, each of these distribution board, we're going to make allowance for 25% spare MCB. Okay, in case of emergency and in case of event, you have to devise a means of providing the spare final circuit breakers. Okay, we're going to also discuss the circuit requirement for that same installation. Circuit requirement entails standard socket arrangement. These are the 3 standard socket arrangement. Ring, radial, we have ring for 1, we have radial 1, we have radial 2. We also have a lighting circuit. Okay, and the power circuit as well. So let me walk you through what this one stipulates. If we are using ring circuit arrangement for this installation, the requirements stipulate that the protective device that is going to protect that particular circuit is going to be 30 amps or 32 amps. I repeat, 30 amps or 32 amps is what we are going to use to protect each of the ring circuit. Then the distance coverage, the length of routing, that's the length of the cable. The cable length, total length of the circuit should not exceed 100 meters. This is the requirement we are going to comply with. Then the cable size for that circuit shouldn't go higher than 2.5 mm square. Remember that the ring circuit should be through and flow. Okay, that is the name, ring. You must form a ring. You must go and come back. All right, that is the meaning of the ring. All right, so I will also show you the picture showing that ring. Okay, that is what I will do. Let me bring out the pictorial view of the ring symbol. Okay, let me do that. Just hold on. All right, this is the ring we are talking about. So if we are using ring circuit arrangement, it's going to be such that, look at the ring. Okay, like I told you about, the arrangement is through and flow. Okay, it's going and coming back to form a ring. Look at the ring, it's forming circle 360. Okay, so look at this one should supply. When it supply round, it's coming back. So both of them should go and terminate on the same MCB. Okay, all right. So the circuit, the current arrangement is such that the current will flow from here and also come back from here. That is the ring. So that is the meaning of ring. You can see that it's being protected by 30 amps. And that 30 amps, each of the sockets should be assigning 3 amps. Okay, let's count number of points making the ring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, number of socket is actually unlimited. Okay, if we are going by regulatory body standard, number of socket is unlimited, but 10 socket point in the circuit is recommended. I repeat again, 10 socket in one ring is recommended, but number of socket is unlimited. But 10 point is recommended. That means 10 socket making one particular ring circuit is recommended. All right. Then if we are using this standard, that means each socket is entitled of 3 amps. And if you multiply these 3 amps by the current, by the 230, we are going to have 690 watts. So each socket point is going to take 690 watts. It's also going to take 3 amps. So if we are using 10 in one of the circuit, that means we are going to use 30 to protect it. Okay, and as you know, 3 times 10 is going to be 30. That is why we are using 30 amps to protect the circuit. All right, then the reason why we are using 2.5 mm square to protect entire 10 circuit point is because this cable in question is going to go two parts, going to form two parts. One part go through here and return back here. So this 2.5 mm square plus another 2.5 mm square coming back is going to give us total of 5 mm squared if you are going in that particular formula. So it's actually 2.5 mm square, but the strength, the current carrying capacity of the cable is actually 5 mm square because it's two cable. One go this way and supply and come back again. So both of them join together to provide this protective circuit. So in that case, the strength is going to be doubled, 2.5 times 2. All right. Okay, so that is requirement for ring circuit. And the advantage of ring circuit is that whenever we have an open circuit along the ring circuit, the current is going to be complete. The whole entire socket point is going to have power because for supposing I have a breakage here, this cable will supply this other second cable will supply the whole of this part. That's advantage of ring. Now, until we have another open circuit in another point again, making second point, that is when one particular portion we have power outage, the rest we have power. Until we have two breakage in the circuit, that is when we have a full disappointment. But if we have only one breakage on the circuit, the entire circuit will still remain complete. All right. Okay, that's advantage, but it's a kind of expensive because the arrangement demand that the piping arrangement will go on two parts. The piping arrangement will go through and flow. All right. So that is why we recommend using radial and ring in installation. In our installation, that that means whenever I want to, let's go to the table. Now, if we are using ring arrangement, okay, we can also decide to use one ring. Then the rest of the socket arrangement can be radial. Because radial, you don't need to return the second part to the distribution board, okay, so that we make it more cost effective. So even the regulatory body also give that recommendation that in your installation, endeavor to use one ring point, then the rest can be radial so that you reduce the cost of the installation. All right. So now this particular installation, we are going to choose ring and also choose one radial. We're going to use one radial, then the rest should be, we're going to use one ring circuit, then the rest can be radial. Okay. But for you to now choose whether you are using ring or you are using radial 1 or you are using radial 2 is now depending on your arrangement of installation. Okay, so let's go back to the floor. All right, let's go back to the floor and discuss. So we're going to calculate this. We're going to calculate the entire ring point, the entire socket point, and now know how to determine which of the ring arrangement is to be used. Are we going to use this second radial? Are we going to use this method, or are we going to use ring or second method? Depending on our total point recovered, because we must work according to the load segregation. What do I mean by load segregation? You are aware that each distribution board, let me show you distribution board arrangement. Now, this is distribution board. Now, the arrangement of distribution board is such that if we are feeding 3 lines to our incomer breakers, the 3 lines must be evenly distributed. Okay, so this one and this one and this one must be evenly distributed.